Okay, question 12 says below is the sketch of the first derivative of f. A and B lie on the first derivative of x, with C being the turning point. C lies on the x-axis. If when x is 0, y is minus 14 on the original function, and when x is 2, y is also 2 on the original function. So here we see on the first derivative graph that when x is 2, that's when the turning point is, and basically that's where the gradient is 0. So we can expect our function to look something like this. Since we only have, okay, let me try and make it a bit more, something like that. And we know that this point here is the turning point when the gradient is 0, and that has coordinates 2 and 2. So if I draw in my y-axis and my x-axis, it would look something like this. I'm not to say we actually don't know when it will cross. Here it's going to the origin, but this is just a rough sketch, and we just know this much about the function, that when x is 2, the y value is also 2, and we know that when x is 2, its gradient is also 0 at that point, meaning it's the turning point. And what we can do is we can write like a mock equation, which will be y is equals to a x minus the x value of the turning point is 2 cubed plus q, which will be the y value of the turning point, which is 2 in this case. The coordinates there are 2 and 2, like that. Then what we want to do is we want to solve for a. So we need to substitute a point that is on our graph, and we're going to substitute 0 and minus 14, the points that were given in the information here. So we're going to put minus 14 for y and 0 for x cubed plus 2, then minus 14 on this side. 0 minus 2 is just minus 2. If we cube, that is minus 8a plus 2. Then we can take 2 to the other side, it will become minus 16 is equals to minus 8a. Divide both sides by minus 8. You get a is equals to positive 2. Then we can come back to our equation and update it and say, therefore we have y is equals to 2x minus 2 cubed plus 2. And what we're looking for is for the x-intercept. Where will it go down? So let me just draw this much for now, because we don't know exactly when it will go down, at which x value. So we put in a y value of 0, because that's when where we get our x-intercept, and we have this. Take 2 to the other side. So let me just zoom out a bit. Take 2 to the other side, get minus 2 is equals to 2x minus 2 cubed. And you can divide both sides by 2, you get minus 1 on this side, and x minus 2 cubed on this side. Take the cube root of both sides. Here you can take the cube root of a negative number, it's possible. So if we take the cube root of minus 1, we just get minus 1. And here we get x minus 2. Take 2 to the other side, will be 2 minus 1, then x is equals to 1. Therefore our function will go down at x is equals to 1. So something like that. At that point 1, that's our x-intercept. So yeah, that's the x-intercept for f, and that's how you would solve it.